Last stretches.
Okay.
Okay,
Hello.
cool. Hello.
This is our video. Okay. Sorry.
Okay. Okay, so we are doing an article, lovely article, on P. destructans and white nose syndrome.
Okay. No.
Next slide, please. Okay, so the origin of this, Pseudogymnoascus destructans is a fungus originating from Europe that was originated from Europe. That was introduced into North America in 2006. It's a recent introduction. Consequently, it is an invasive species to North America and has a massive native impact on the bat population. So, like, why is being introduced slash non-native species important? This is because the bat population in North America did not have much time to build up said resistance to the fungus, unlike the bat populations in Europe who already had plenty of time for that. So this allowed P. destructans to rapidly decimate the bat population, literally killing millions of bats and causing them to practically go extinct. There are plenty of other examples of this happening, and some are more recent, including the spotted lanternfly, emerald ash borer, chestnut blight, and plenty of other examples that have decimated populations within North America species. It was originally only found in a singular location in New York, although it has since spread across the United States and parts of Canada and cloned itself multiple times. It really only showed how it's really only showing how dangerous and easily spread invasive species are to the ecosystems. However, the article does not state anywhere where specifically in Europe the strand is related to, nor how it originally came to North America. But that is kind of similar to how other non-native species have gone here. Next slide.
Yep.
I believe this is the effects. So I believe,
Well, this is the
oh yeah,
graph.
this is actually a map of the spread of the white nose syndrome, specifically, I guess, like really the fungus that causes it from 2006 all the way to 2017. And it's mostly in winter because, well, it'll be explained later in the slides.
Specifically just because how the fungus infects the bats is through during their periods of torpor, which is just temporary hibernation, which is explained in the next slide. So effects on the bat population. So Pseudogynococcus destructans, P. destructans, is the fungus which causes white nose syndrome. The reason why it has that name is because the when the fungus attacks and colonizes the bats during their torpor or temporary hibernation during the winter, it spreads on the nose, the ears, and then also its wings, causing the white nose that you see in the picture. So basically, what happens is so during hibernation, temporary hibernation, the fungus colonizes the bat, its tissues, um, which causes the bat to awaken more frequently, which then depletes its fat reserves, which is crucial to its survival because obviously during hibernation there's not a lot of food resources, so they need to conserve their energy. But by waking up more frequently, that reserve is rapidly decreases, causing them to starve to death. Um, in this case, sorry. um, Though not all bats die during the winter, sometimes they survive the initial colonization, and then in the spring when spring arrives and they awaken because the fungus has infected their tissues through on their nose and their wings and their ears. The bat's immune system will kick in and attack its own tissues, causing eventually death. So two both terrible ways to die. The effects of this fungus, however, do differ based on population, specifically between European bats and North American bats. Mainly, as said in the previous slide, because of just how long the fungus has been in those areas. So just coevolution between the European bats who have had to deal with this fungus for longer, and then the North American bats who have just been recently introduced to this deadly fungus. So in European bats, they can coexist with the fungus, although the fungus does cause um, lesions, cutaneous lesions on the bat. So obviously not great, but they can still survive. Um, in North American bats, the mortality rate is between 90 to 100%. So if the bats get it, they're most likely going to die. Um, so yeah, next slide.
Okay, I believe this would be the mutations. Yes, okay. So the mutations in genetic diversification, P. destructans, since its introduction to the United States, it has gone through multiple genetic mutations, despite being only a clonal group of the variant within somewhere in Europe. And so how does this become a cause for concern? Well, as mentioned in previous slide on its effects on bat populations, it can potentially become even more harmful for the bat species that live in the United States and also Canada, having it mutate and cause it to become even more efficient in its virulence, which is basically it being more effective at like infecting and other stuff, like basically be more deadly. Having said that, the article states that the genetic mutation it has gone through is mostly, if almost not entirely, nuclear mutations compared to the original strand it was found to be a clonal colony of. Now, why is this important to note? It's because like it demonstrates that it's going through the beginning stages of genetic diversification. Although it's not quite in the stages of natural selection just yet, it is going through this, should be really raising alarm bells. And why is this really, well, further concerned, slash why is there a large range of variants? The reason is because P. destructans is due to a natural selection not yet acting upon it. So as there was not enough time for it to, pretty much just like not enough time for it to act upon it, thus creating the spontaneous mutations, and like it can create more mutations as nothing's really stopping it from doing it yet. So which really only proves that it's like really just going through that early stage of genetic diversification. So pretty much it has not gone through any recombination as stated in this article as of yet. This article thus it has not created new alleles as the article states that. However, it is a possibility that this can occur.
It's basically new combinations of alleles, not like
Yes, not recombination of alleles, not like entirely new alleles. That is a little bit more concerning. Next slide, please. Okay, so this is a graph in the research article that like basically the researchers observed that the base spectrum of mutation with its clonal variants had pretty much a very high degree, as you can see right here, of the C to T. Pretty much this kind of coincides with the de novo mutation spectrum of other specimens of fungi and other creatures, which really just, again, further emphasizes that it's really only in the early stages of diversification.
yeah.
I believe next slide.
Okay, so resistance. So as previously said, this is mainly catastrophic for most hibernating bat populations, which should be emphasized because not all bats do hibernate. However, there have been a couple species who have either from its first introduction of the fungus have been resistant or have developed resistance because of the host and pathogen interactions. So, Epitus fuscus, since the introduction of the fungus, has been resistant. It has not faced the same mass mortality as other bat populations, as shown in this graph from the Williams cave mines. The E. fuscus bat population before the introduction of P. destructus from dates 2000, 2001, 2003 was relatively low. They comprise a small portion of the population within the Williams cave mines. However, after the introduction, because a lot of the other bat populations were dying off, the its population grew exponentially because of of it not being affected by it and not having the mass mortality as the other bat populations were experiencing. And then M. Fuscus, originally it was hit pretty hard by the introduction of the fungus. As you can see, in the same graph. Um, it originally had between, within the small population area of Williams cave mines, had between 100 to 120 to 200 individuals of M. Lucifus in 2000, 2001, 2003. However, that immediately decreased with the introduction of the fungus, decreasing to like around 31 individuals in 2009, and then 24 in 2010. So it was immediately hit pretty hard. However, um, as of 2017, when the article was written, there has been a slight rebound in the bat population um, of M. lucifus, indicating some sort of developing resistance to the bacteria. Not bacteria, fungi. Wrong thing. Um, uh, Also, it's important to emphasize while no recombination has occurred yet, um, uh, because of its parasexuality, because it's a clonal population, meaning there is no diversity between like the sexes of the fungi, meaning it cannot perform sexual recombination. If a new introduction of the fungi were to come into North America, it could perform sexual recombination, which is a lot more concerning than parasexual recombination. So parasexual recombination, recombination occurs in parasexual recombination through accents during mitosis. However, for sexual recombination, this occurs during meiosis. And why that difference is crucial is because during meiosis, that produces genetically different daughter cells. However, during mitosis, the daughter cells are genetically identical to the parent cell. So because of that, recombination obviously is going to occur a lot more frequently during sexually recombination, and thus creates more genetic drift between the populations, which then can increase virulence. So as the bat population develops its own resistance, the fungi can then develop its own reaction in response to that resistance, making it more virulent, and then can obviously have massive effects, as we have seen, on the bat populations. So yeah, and this is our resources. So there was the main research journal article that we used, and then also the graphs and photos. Thank you.
Yes. Thank you for listening.